My name is Eugene Kutzajam, and I'm here today with Electronics or Bruteforce Engineering. We started this company to inspire and to nurture the culture of research and development and product development in Zimbabwe. So we started as Netro Electronics just by selling components and making them accessible across Zimbabwe. We had agents across other universities, and we were also distributing our gadgets through services like FedEx and DHL. So the goal was to make technology more accessible to everyone in Zimbabwe, so that we can have our students focusing and working on solutions, homegrown solutions to the challenges that we have in our country. So moving on, that was in 2017 when we started Netro Electronics. In 2020 we started Bruteforce Engineering. With Bruteforce Engineering we then moved straight into research and development. That is where we are now doing projects. So one of the challenges that we realized is that it was very, very difficult across the world actually to move from a prototype to a finished product. So we even realized, even from our own experience by trying to make a product, because sometimes as technical people, we have the challenge where we have an ability or we have certain skills, and then we work on a solution, then we bring it to the market, and people are not really aligned with that, or they do not see the same challenges, or they do not even see what we've done as a solution. So then that's the challenge we have, that sometimes you can work on a project, then bring it to the market, and then that is not what people are looking for. And because of that, at the same time, research and development is a very, very, very expensive industry. It's a very, very expensive process, because sometimes you make a lot of mistakes, and it's very, very costly in terms of the components that you are buying, but sometimes they burn. Sometimes you realize that you used a less durable sensor, you need a more durable sensor. It takes a lot of time. So this is the challenge with R&D. It's very slow and it's resource intensive, and at the same time you do not have a client for the products that you are developing. So what we then decided to do was we looked at most of the projects that we do, and we decided to generalize them and see how can we make a product that we can turn into anything at any time. So it then becomes like a foundation for different projects. So what that then allows you to do is that if you make a product today and it's an automatic sanitizer dispenser, tomorrow you can even add another module and then it's connected to the internet. Tomorrow you can remove those sensors and put new sensors, and it becomes a device that is working in a greenhouse without needing to change a lot of things. So it just makes it modular. It makes it cost effective, and it then also makes it easy and more robust. It's now easier to make a product from a prototype to a finished product. At the same time, you can even have one casing for all your products. All you now need to do is now work on your program instead of working on the hardware, because hardware, as the word says, hardware is hard, but then when it comes to software, it's soft. So it becomes easier. So now your focus is no longer on hardware but on software. So you can change your product just by changing the program. So that is what we have been able to do. So here you can see some of the boards that we have. This one is the equivalent of an Arduino Uno, but we have made it in such a way that it don't really need to use what we call a breadboard, which is an extension of this board. Then you have many cables jumping between that and this board, which is very, very tedious and untidy. At the same time, we have also developed other boards like this one, which is a robotics board. It is equivalent to the Arduino Uno board. We call it, this is Malcon Smarts and this is Malcon 1. By the way, that's the name for our boards. They're called Malcon boards. So on this board you have other, what we consider basic components, which you normally need for different projects, because on the Arduino they are not included. But then we included that, for example, we have an LED over here. Almost every project needs an LED. We have a buzzer here. Almost every project needs a buzzer. For sound, we have an IR button here. Actually, IR receiver. This works now with a remote. You can now press buttons and you can send commands to this board. We also have here we have a port which you can put your Wi-Fi module, and here we also have a port which you can place your radio module. Therefore your board can easily communicate wirelessly. So moving on, also we changed and we introduced the Type-C to the Uno board, which is now the standard and basically a very common USB cable to find around your homes. So these are the small boards. This one was based on Arduino, which is Atmega 328. This one is a similar board, but it's based on ESP boards, expressive boards. And over here we have the bigger version. This one is more of it then moves to more robust solutions where you want to build like smart homes, or you even want to do some basic controls even in some industrial systems. We have deployed this in a number of industries, not a lot, but we actually have some of these working in industries in Zimbabwe, and we've used these also for greenhouses. What this one is then are these relays. Relays now allow us to control other external circuits. For example, we can now control your lights, we can now control your pumps, we can now control motors, we can now control gates and different things. But it also has other basic features as this one, which is we have the remote receiver here, IR receiver. We have the buzzer here, and we have our LED light there, and also at the same time we have this port, and this port is the same. We now have these external connectors, so it makes it neat and smart to make your connections. These connectors, the way they work as this one. Here you can see you just plug it in, and then you have your cables. It's easy to connect, and then you have these screws which can tighten up your cables, which is then different from some of the boards that we have here or which are on the market, which you have to use maybe glue gun, super glue, or things like that to make sure that your cables are tight. For example, as you can see, this is what I was explaining. This is what we call a breadboard, and these are the cables. So you can see that this connection is actually okay. So this is an example of a circuit that has a breadboard and a microcontroller. So you can see that from these connections, like there are many cables, and then you can see that we have this is a Bluetooth module, but then with a development board for like this one for robotics. So the controller which they use, this one is actually not the right one. They were supposed to use this, but this serves to demonstrate the difference between this board and this one. So for this one, you actually need an additional component which we call a motor driver for you to be able to drive these motors, which is here on this board. Right, so all these cables are here because you just need to control the motors, but with this board now you have your motor driver here, and your motors are connected here directly, and that makes it very, very easy. For the USB, this is the Bluetooth module. It can go directly. It has some pins. It can go directly here without needing any external wires. So this is how our boards simplify robotics and electronics for students and engineers alike. Then moving on with some of our products. For example, these ones are our egg incubator controllers. The controller inside, it looks like this. Inside this, it looks like this one. And at the same time, even though this is an egg incubator controller like we explained, you can reprogram this and use it in other solutions. So this is available as an egg incubator. At the same time, it is available as a development board for people who want to build solutions. But already, as you can see, it's in a casing, and if you do your project, then it's a complete product. All your connections come here. At the same time, we've maximized our use of the board by exposing the unused pins inside here. So here, for example, you can plug in a GSM module, which you can plug in a SIM card, and then you can have internet connection, GSM calls. You have all of that technology from here, and here we have what we call I2C for LCDs and different things like that. So this is how we've developed our boards. So for these boards, we have for AC and DC. The AC, you can use your power supply from the electricity grid. At the same time, the DC ones you can use directly with solar, 12 up to 24 volts. Whichever voltage you plug in, the board is ready to work with that. Moving on, some of the products we have here, these are LPG gas detectors. smart LPG gas detectors. As you can see, of late in Zimbabwe, we are seeing fires sprouting around in different places because of maybe LPG gas, or maybe someone was reckless by, I don't know, however they started the fire, maybe by electrical connections or whatever type of negligence. These types of devices will be able to assist us in those cases. How it works is that it has a gas in the smoke sensor, so it can detect when there's a leakage or when a fire is starting, and then it can give you a call, it will send you an SMS, and it will make a noise. In another case, we can then connect this valve to your, we did not make this is a ready-made product. Okay, so you connect this to your gas tank and then to this device. When there is a leak, and if you are lucky that your leak is after this device, then this device will cut off your LPG gas and your home is saved from fire. But at the same time, because it has given you a call, you can then take the response to the fire threat. Moving on, what we are seeing here is the first version of our vehicle tracking development board. It's a development board, at the same time it's a finished product. Like we said, we can sell it as a finished product to users, but we can also sell it to fellow engineers who can then program and customize their own code with this board. Moving on here, what we have, these are the speed limiters which we were talking about. As far as we are concerned, these are the only speed limiters which are manufactured in Zimbabwe, designed and manufactured in Zimbabwe. So what we do is we design our boards, and when they come, we place the components, as you can see on this board, SMT components, and we solder them on, and then we place them in these casings. That is our manufacturing processes. So to date, we have sold about 2,000 of these units. We have these units on buses and trucks. It's a matter of safety. So you can imagine if you have a device on a bus that is carrying 65 people, 70 people, then your device has to be up to standard. So up to date, we have had no complaints about our devices, and they have not contributed to any fatalities whatsoever. The only challenges that might be faced during installation before the device has been deployed. So we are very, very proud of this device. It is one of the devices that we have been able to mass produce and sell to the market. Like I explained, it is very, very difficult to make a product, especially in a market like Zimbabwe. People are focusing on needs. They actually going to buy a product that they need, not a product that they will use for fun. So that has been our first breakthrough product. Hopefully next, we are looking forward to releasing the egg incubator controllers, and we look forward to be selling these in large numbers. I think